We are going to measure two physical quantities in an electric circuit. One physical quantity is electric current, I represented by I. Second physical quantity is electric potential difference represented by V. Electric current is measured by ammeter. Okay, this is very important. We will talk about this again. Electric current is measured by a device called ammeter. Its symbol is A. If any device, an electric device on the surface of which is written A, it is an ammeter, and it measures electric current. Any device which measures potential difference is called voltmeter. Voltmeter. On the surface of the device, V is written. Voltmeter, ammeter. So how to measure electric current and how to measure electric potential difference? Now I am going to talk about this. First one, measuring potential difference, electric potential difference. First, let me talk about, again, gravitational potential difference. How can you measure gravitational potential difference between the point A and point B? If you measure the height and difference in positions between A and B by using a ruler or meter, so you get H, how much? After that, you multiply M times G times H, you calculate the potential difference between point A and B. But one end of the ruler must be put at point B, other end of the ruler must be put at point A. You should check the difference between these two, which is H. Electric potential difference is no different than the measuring the gravitational potential difference. So electric potential difference, as I said, is used by using voltmeter. Voltmeter has two terminals. One terminal is represented by red, which is positive terminal. Other terminal is represented by black, which is negative terminal. These two terminals of the voltmeter must be connected between the points, across the points, between which we are going to measure the potential difference. For example, here is an electric circuit. You see that. This is a battery, EMF source. This EMF source is a positive terminal and a negative terminal. So there is a lamp. And I want to measure potential difference between the terminals of this lamp, between the ends of the lamp, and between the points B and C. If I want to measure the potential difference between the points B and C, I have to connect this voltmeter's terminal, one terminal to the B, other terminal of the voltmeter to the C, just like this. So this terminal, positive terminal, is connected to the B, negative terminal is connected to the C. In this case, you are going to see that this voltmeter starts reading some values. Whatever the potential difference is between B and C, you are going to observe on the scale of this voltmeter that value. Say that potential difference is written measured by 1.5. So in this case, you are going to say that, yes, potential difference, these 2 points B and C, is 1.5 volt. So electric potential difference symbol is V, and its unit is volt. If you measure 1.5 volt, so you are going to represent it like this. V is equal to 1.5 volt, or V is equal to 1.5 V. V represents the volt. So before passing to the electric current, now I will ask a question to you about the previous titles. We learned that electric current always moves from a point at a higher electric potential to a point at lower electric potential. And tell me, which terminal of the battery has a high electric potential, A or D? Which one?
I think it's A.
Because it's positive, correct. And electric current starts from A and continues to the B, from B to C, C to D. One more question. Which end of the lamp has a greater electric potential, B or C? B or C? Look at the electric current direction.
B.
Electric current always from a high electric potential to low electric potential. That's why B will have a higher electric potential than C. Then, by looking at the direction of the electric current, you can say Which point has a greater electric potential? Which point has a smaller electric potential? Because electric current is from B to C, B will have a high electric potential than C. How much greater? The measure of the voltmeter. If voltmeter measures 1.5 volts, so point B will have a greater electric potential than C by 1.5. If you measure by voltmeter 2 volts, point B will have a greater electric potential than C 2 volts. So by using this device, which is called voltmeter, you can get the difference between the electric potentials at the end, between the ends of a device. We will measure now electric current. By the time, we don't always draw such a diagram. Instead of this, we are going to draw a schematic diagram for voltmeter, how to measure the potential difference. So, in an electric circuit, we have a battery. This is the battery. So this represents the battery. This is the switch. This is lamp. And this represents voltmeter. So you're not going to always draw this. Instead of that, you will draw its symbol, voltmeter. And as I said, voltmeter has a positive terminal and a negative terminal. Always, positive terminal of the battery must meet positive terminal of the battery. So otherwise, you cannot measure potential difference. So this connection is named as parallel connection. Positive end of the voltmeter must meet with the positive end of the battery. Negative end of the voltmeter must meet negative end of the battery. In this case, you can measure potential difference between the ends of the lamp. And measuring electric current. Electric current is measured by a device called ammeter. So on the surface of this device will be written A, ammeter. It represents ammeter. Ammeter also has a red and black ends. Red is positive, black is negative as well, just like voltmeter. But ammeter is a counter. It counts the amount of electric charges passing through a conductor in unit time. In our life, in fact, there is other counters. For example, this counter for water, it counts water, how much water passes through the pipe. So all counters are connected along the path of the quantity which must be measured. For example, if you want to measure how much water passes, you have to connect this water counter on the pipe along the path of the water. Same thing will be done for ammeter as well. Ammeter is a counter. It counts the amount of electric charges passing through a conductor at any time. So it is connected on the path followed by an electric current. Just like this. So this is a simple electric circuit. There's an EMF source, a battery, a switch, and a lamp. And we know that if you connect EMF source to a lamp, so electric current starts from positive, goes to the lamp, from lamp to the switch, from switch to negative. So you should put ammeter along this path. Yeah, and you can put it in here, you can put it in here, anywhere you want. You can put ammeter before and after the lamp to measure how much electric current passes on the lamp. So because in here, when electric current starts from positive end of the terminal of the battery, first the electric current passes through the ammeter, then passes through the lamp. So same electric current passes through the ammeter and passes through the lamp. That's why ammeter is connected to a device in series. In series means one after another. Just before the device or after the device. Ammeter is connected before or after a device through which electric current passes. This connection is named as series connection. So ammeter is connected to a device in series, but voltmeter was not like this. Now let's go back to the voltmeter. So voltmeter connected in parallel. Look at them. What does parallel mean? One end of the voltmeter is connected to the one end of the device. Other end of the voltmeter is connected to the other end of the device. This combination is called parallel. But this is series. So just one end of the ammeter is connected to one end of the lamp. Other end of the ammeter is connected to the battery, not the lamp. This combination is known as series combination. And again, Ammeter also has a positive terminal and a negative terminal. Positive terminal of the ammeter must be connected to the positive terminal of the battery. Negative end of the ammeter must meet negative terminal of the battery as well. Yani positive end of ammeter must meet with positive end of the battery. Negative end of ammeter must meet negative end of the battery. Any questions about how to connect ammeter? Yes, Vanya?
Like the only difference between voltmeter and ammeter was like how they are placed in a system. One of them was parallel.
Voltmeter is connected parallel with the device and it measures potential difference. And ammeter is connected in series, but it measures electric current. So they measure different physical quantities. One of them measures potential difference. This is a ministry exam question by the time. Ammeter measures electric current. Voltmeter measures potential difference. This is ministry exam question.